This is a demo for showing the energy savings. We have the F7, our power meter, and as you can see it's showing 207, 205 voltage. We have our smart relay connected to 3 contactors. This one actually is a starter for a direct connection of the motor, B1000 and the F7. And then we have our selector switches over here. We have the connection of the amp meters, and as you can see I have to make a small coil because it's way too low of a current to be reading by the power meter. We have our voltage test at the input, and let's do the first run. Actually, what we can do is to select this one in position number 1, and we can start our motor, so you can actually see the current. See, you can actually see the current just with the streak of the motor, and you can see the vector there. And right here, what's most important, you see the power factor. Those numbers are almost fixed because the motor is running at full speed. Okay, now I'm gonna shut this off and turn the B1000 on, and you can see the numbers again. You can see it's increasing the speed. You can hear that it's doing the acceleration, and you see the power factor corrections. See the numbers here of the power factor. Okay, now I am going to go to the previous reading, so you can see there is the same amount of current. And as you can see on the flow on the meter, you are using 3.4 amps at 60 hertz. Okay, this is just connecting the motor with the drive, not auto tune, and the energy savings not energized. Now we're going to do the auto tuning. So pretty much what I'm gonna do is I'm going to go into auto tuning, click enter, and I'm going to do the standard, which is going to make the motor to turn. And over here I am going to set it up. Since this motor is a 2 horsepower motor, 2 horsepower is equal to 1.5 kilowatts. So I am going to change the kilowatts here. Enter. Now that I see the voltage, I am going to set the voltage up to 208. Okay, I am going to set up the amperage of the motor. As you can see, the amperage of the motor right here, it says 7.6 at 230 volts, or 3.8 at 460. Okay, so that's the full amperage, and this is important because you need to protect the motor. Okay, 60 hertz. Number of full poles is 4 because it's 1700 RPM. The RPM of the motor is 1755. Okay. Now it's telling me that I need to push the start button in order to make okay, so we have the auto tune ready. We're going to put the run, and what you want to do is you're gonna start seeing applying 0 hertz, 0 speed, and it start increasing the current. Now you can hear the motor not turning but increasing the frequency in the motor. Okay, 0.5. The motor is still not running, and then you're gonna see a motor running sequence. That's not an alarm that somebody's chipping. Now, as you can see, is running the motor. You can actually see reducing the current on the motor at 48 hertz, and that is going to make this motor running more efficient. And it's looking right now for the best current possible for that motor to run. Well, this is running. I am also recording right here. We're recording all these moves. See, still doing it. Now finish, tune successful. Okay, so you just press menu and enter, and you are ready to run. Now, if you remember previously, the drive was running. Drive was running at originally when we did the first connection was running at 4.5 amps. We did the auto tune, and then it go down to 3.5 amps. Now I reinitialize the drive, so it goes back to the factory settings. Now we just have to run it again. So we're going to run it again so you can see what the amperage the auto tune dropped. So after the second start, it was running at 3.3 amps. Now let's start it right now and see what the amperage drop right here. 47, 48. See, it's running at barely 3 amps. So just right there, you just lost or lose 0.5 amp. Just by doing auto tuning, you're saving energy right now. All right, now we're going to energize the energy savings functions of the drive. I just pass programming, enter, and what I'm gonna do is I'm gonna go to B8. Okay, B8. Click enter, and I'm gonna energize without modifying any parameters on the energy savings. You can actually fine-tune the energy savings that you want to have, but you will have to do a lot of calculations. So right now I'm enabling. Okay, I'm going to get menu operations. Now you're gonna see the amperage here, and that's how the drive is going to save energy. Now you see, before it was barely 3 amps, now it's 1.244. So right there, my friends, is energy savings. Okay, I was telling you about the energy savings. You're gonna see dropping here. Okay, this is one of the questions that the customer is going to ask. Now right now I have 60 hertz. Okay, I'm gonna start reducing the hertz on the drive to 45. So you can see 45 still has a lot of inertia on the motor, and is using that inertia. You're still saving. Now if we bring it down to 30 hertz, okay, you generate inertia, but not enough. See, you still having a 2 point, so it's not enough inertia to save energy. Now if we bring this down even farther at 50 hertz, you're gonna see this one. Actually, it's pretty good there. Sometimes when you get to 50 hertz, it's actually double the amperage. So you can actually see it right there. The amperage at 13 hertz. Now this is important also because now you can come over here and you can show the customer, you know, all these peaks. That peak is without the drive, and then you can see the peaks with the drives right there. No peaks, no inrush current. 1.24. You see the amp transformers connected the same, but take a look at the amperage on the meter. 0 amps. That means 1.2 amp is way too low to read it, and it's still running. So this is something to take care of. Now it's using energy. You can actually see here it's changing. So pretty neat.